students, how are you all? Hope you all are safe and fine at your home. So students, welcome back in your mathematics class. This is class 9th, chapter 10 circles. This is our lecture number 8. So students, in this lecture we will discuss remaining questions of exercise 10.5. So question 1 to 6 I already discussed in previous lecture. Now we will discuss question number 7 onwards. Question number 7. If diagonals of a cyclic quadrilateral are diameter of the circle through the vertex of the quadrilateral, prove that it is a rectangle. First of all, we have to draw a diagram. This is a circle and this is a cyclic quadrilateral A, B, C, D, and these are the diameter of the cyclic quadrilateral bisect at point O, which we will take as a center of the circle according to the question. What is given? He said the diagonals of a cyclic quadrilateral, it means ABCD is a cyclic quadrilateral and AC and BD are diameters of circle according to the question. And now what we have to prove? To prove ABCD is a rectangle. So student, first of all we have to prove that two things in it. According to the properties of a rectangle, a quadrilateral whose opposite sides are equal and whose angles are 90 degree, all angles are, is a rectangle. So we have to prove all these things. In this question, cyclic quadrilateral, then we know that one property is there, then opposite angle sum 180 degree. If we will try to solve and prove that they are equal to each other, then the sides are also equal and they are 90 degree. So proof AC is a diameter, correct? If AC is a diameter, then according to theorem 10.9, that angle in semicircle is 90 degree. If angle is present in a semicircle is 90 degree according to the theorem, so according to our diagram, angle ABC is 90 degree and angle ADC is also 90 degree, correct? Is a diameter, then according to the theorem, angle DAB is equal to 90 degree and angle BCD is equal to 90 degree. So students, according to these two equations, all angles are 90 degree. If all angles are 90 degree in a quadrilateral, then hence we can say that ABCD is a rectangle, correct? So student, this is your question number 7. Now question number 8. Question number 8. Question number 8, the statement is if known parallel sides of a trapezium are equal, then prove that it is a cyclic. If we are going to prove that anything is a cyclic, so first of all we have to draw a diagram. This is a trapezium. So if we are going to prove that it is cyclic, then we have to prove that sum of opposite angles are 90 degree. This is a trapezium according to our question. What is given? trapezium ABCD in which AB parallel DC, and according to the given condition known parallel sides are equal, and we have to prove that ABCD is a cyclic. Proof: we will draw two perpendiculars from this vertex on the given base. We will mark them as E and F. E and F. So draw DE perpendicular on AB and CF also perpendicular on AB. We are going to draw two perpendiculars. Now students, according to the cyclic quadrilateral, we have to prove that B plus D is a sum of the angle B plus D is 180 degree and A plus C is also 180 degree. It is sufficient to prove that ABCD is a cyclic trapezium. So now we will take in triangle DEA and triangle CFB. In both the triangles, AD is equal to BC, given angle DEA is equal to angle CFB, each 90 degree, and DE is equal to CF. Because these two lines are parallel, it is given, and the distance between two parallel lines are always equal. So what we have to written here, distance between two parallel lines are always equal. So students, by RHS congruence rule, we have triangle. These two triangles are congruent. Then angle A is equals to angle B by CPCT, and angle ADE is equal to angle BCF are also by CPCT. Now students, we will take in triangle, small triangles, ADE is equal to BCF, we proved above. If we will add 90 degree on both sides, because when we will draw a perpendicular in your diagram, if these two small triangles are equal to each other, if we will add this 90 degree on both sides, then we will get the complete angle. So 90 degree plus ADE is equal to 90 degree plus angle BCF. So students, now it is angle D is equal to angle C. Angle D is equals to angle C. We are already proved that angle A is equal to angle B. So we know it very well that angle A plus B plus C plus D is equal to 360 degree. Angle sum property of quadrilateral. So A is equals to B and C is equals to D. We can change according to us. We want B and D. So we will change both A and B as B, and C also D, and D also D. Then it is double of angle B plus D is equal to 360 degree, and B plus D is equal to 360 divided by 2, which is equal to 180 degree. Now with this relation, we proved that ABCD is a cyclic quadrilateral. Now this is your question number 8. So now students, question number 9 is a very easy question. You have to try to attempt it. And question number 10 is same as example number 5, which is present in your NCERT. Now we will discuss question number 11 and 12. Question number 11. Question number 11 statement is ABCDADC are two right triangles with a common hypotenuse AC. Prove that angle CAD and angle CPD are equal to each other. So students, first of all we have to make a diagram. He said ABC ABC is a right angle triangle and ADC, and both the triangles have a common hypotenuse AC. So like this, here we have 90 degree and 90 degree, it is D. And now students, we are going to prove that angles CAD, this angle, and angle CBD, it means we have to draw this angle. So first of all we have to draw a circle, and we have to make this quadrilateral as a cyclic quadrilateral. So now according to the given condition, angle B and angle D is equal to 90 degree, and to prove is angle CAD is equal to angle CBD. Proof. It's given that angle B is equal to angle D is equal to 90 degree. It's given, and AC is a common hypotenuse. Correct. This is only possible when, if these two angles are 90 degree, this is only possible when AC is the original diameter of the given circle, because angle in a semicircle is only 90 degree. Angle in a semicircle is always 90 degree, is always 90 degree. So students, AC is diameter of circle. AC is the diameter of the circle. Now according by arc DC, angle CAD is equal to the angle CBD. Why they are equal to each other? We have to give reason. Angles in same segment, because we know that when two angles are present in a same segment, they are equal to each other. For this we have to prove it. These all four vertices are lie on the circumference of the circle. It means it is a cyclic quadrilateral, and we already proved that these two angles are 90 degree. Then AC is the diameter of the circle, and by an arc these two angles are drawn in a same segment, so they both are equal to each other. Now question number 12. Question number 12. Prove that a cyclic parallelogram is a rectangle. Cyclic parallelogram is a rectangle. We have to draw a circle first. A, B, C, D. This is a cyclic parallelogram. It is given. So what is given? First of all, A, B, C, D is a cyclic parallelogram. First, we know it very well that parallelograms condition that opposite sides are equal and parallel opposite angles are equal, and we know also the cyclic conditions that some of the opposite angles are 180 degree. To prove ABCD is a rectangle. ABCD is a rectangle. So students, proof because ABCD is a cyclic parallelogram. First equation, when ABCD is a parallelogram, then we know that A is equal to C. Equation number second, if ABCD is a cyclic parallelogram, then angle A plus angle C is equal to 180 degree. Property of parallelogram, property of cyclic quadrilateral. From equation 1 and 2, angle A plus angle C is equal to 180 degree. So angle A plus angle A is equal to 180 degree. It means angle A is equal to 90 degree, which is equal to C. Similarly, we can prove that angle B is equal to angle C is also equal to 90 degree. Hence, ABCD is a rectangle. Okay students, so students, you have to try hard for these questions. You have to do them honestly, and you have to try your optional exercise 10.6, exercise 10.6. So now today's homework. Do questions of exercise 10.5 and do questions of exercise 10.6 1 to 4. This is your today's homework. So students, do good, have good. Thank you. Have a nice day.